New Zealand volcanologist Richard Wysoczanski is one of the scientists investigating what is thought to be the largest ever eruption in New Zealand waters. In fact, scientists are learning how lucky we were this eruption wasn't on dry land. Richard's part of a team of scientists that sailed from Auckland to begin research into the eruption under the sea back in July, about 500 k's north of New Zealand. And this eruption created what we've heard about, the massive raft of pumice on the surface of the Pacific, estimated to be about 482 kilometres long and 48 kilometres wide. Richard Wysoczanski is with us now. Good afternoon.
Good afternoon, Jim.
Now, Richard, where are you?
We're on the Tangaroa, the NIWA research vessel, about 100 kilometres off Cape Turnagain on our way home to Wellington.
Right, okay. You're steaming down the coast.
We are, yes. Time to go home.
Time to go home. What a trip you've had. You've been up in the area of the explosion. Now, did you see any of the pumice?
We did. We saw a lot of the pumice. It tracked us. Well, we were trying to track it as it actually tracked us, all the way from the volcano, about 100 kilometres west and also south of it. So it's definitely still out there.
I wonder where it's going to end up. It's obviously floating somewhere.
Towards Australia, by the sound of it. It'll get waterlogged and eventually sink, and we know a lot of it's already sinking. We sampled some of it about 200 kilometres away from Harbour Volcano.
Oh wow, that far away already. You've been collecting some of it, I think, Richard. For what purpose?
We would like to study the chemistry of the rocks to get an idea of how the eruption occurred, what brought it on, how large it was, and to gain an insight into what leads up to an eruption in terms of magma chambers and the movement of magma, and how they're associated with earthquakes as well. It seems an earthquake might have triggered this particular eruption. We know so little about how these things build up, and it's important to understand what happens, especially for the volcanoes closest to New Zealand.
With that amount of pumice, it was a very big eruption, Richard?
It was. It was several cubic kilometres, so it's probably a couple of times the size of Rangitoto, if you imagine two whole new volcanoes being built. That's the size of it. Luckily, it was about 800 kilometres from New Zealand, but there are many volcanoes closer to New Zealand that it could occur on, or even on land.
So if it had occurred on land, just hypothetically, it would have been a severe disaster, I'm thinking.
Absolutely. It would have been 3 to 4, maybe 5 times the size of the Tarawera eruption in the late 19th century, which killed over 100 people and caused quite a lot of devastation around Tarawera. So
wow.
Much larger than that. Much
larger than that, okay. And that pumice raft actually was a huge size itself, wasn't it?
It is. It's quite thin, so it covers a lot of area, but the volume isn't that big. But certainly if it occurred on land, you would be talking about a lot of ash cover covering a lot of New Zealand. So in that sense, it's quite important to understand exactly what happened.
Richard Wysoczanski is with us, so you won't fully understand yet, but had you expected an eruption in this area?
Well, we do. There are 40 volcanoes, and we know there have been, there's been one small eruption a year or so for the last decade that we know of. A lot of them are 1,000 metres below sea level, and there could be a lot more. This is a much larger one. It was a question of when something would happen, and there will be more, but we have no idea about the timescales. So it was a surprise, but not unexpected, I guess.
All right. And the only sign of this was the earthquakes preceding it?
There was no sign until the Canterbury came across it.
Okay.
Then I think people looked at the record and saw it was Harbour. Yeah.
All right. So that was ascertained in hindsight. So what have you done? You've taken core samples down there too, haven't you?
We haven't taken core samples. What we do is deploy baskets and sleds to the seafloor to scoop up some of the material. So we have quite a lot of that, which we'll take back with us and analyse.
Okay, so you'll analyse the sea floor itself, and what can you glean from that?
Really about how the magma system works. What type of magma is down there, how many types, it seems there were several in this one, and also how explosive the eruptions can be. And the interesting point for this one was that it managed to get through 1,000 metres of water to disperse all that pumice. Now, if that eruption happened in shallow water or on land, that water column's not there to keep the pumice down. So it would be quite devastating if it occurred in those regions.
Yes. Could those volcanoes be a danger to us?
Well, yes. If you think of it in terms of Ruapehu's distance to Auckland, it's about 300 kilometres. Well, there's about 12 volcanoes at least that size, as close to New Zealand. So there are a lot out there.
Right. And you've been seeing generally about one eruption a year, or albeit more minor ones from this group of volcanoes?
Well, they are minor ones, but if you equate it to Ruapehu as well, that had small eruptions, but we know it's capable of very severe ones.
Yes.
So it's a matter of time before something like that happens. And some of the larger volcanoes can possibly generate tsunami as well. So they're a definite hazard, but we just don't know the timescales of these eruptions.
Yeah, and okay, so you can't really ascertain much more than that at the moment. When you get back to the lab, what else do you think you might be able to find out, Richard?
We'd like to do a lot more work in terms of looking at the record of how often these eruptions occur, and we are doing that for some of the volcanoes. A student at Victoria University, Kirsty Herbert, is working on that right now to try and ascertain exactly how often these things erupt and what size the eruptions are, and only through that can we really gain some idea of the volcanic risks in New Zealand.
Do you think you'll be able to ascertain, well, is it possible that you might be able to ascertain any kind of trend in terms of the behaviour of the seafloor and those volcanoes?
Yes, well, we're already starting to do that. It looks like the individual volcanoes at least go through periods of quiescence and then they start up, and in fact whole fields may do that. We know that from the on-land record, and it's looking like that in the oceanic as well. We just happen to be at a time where a lot is happening.
Right, so we may be seeing an awakening, we just don't know how big.
Well, we're an awakening over hundreds, thousands of years, yes. And we have no idea what's going to happen. We do know the geologic record tells us there have been some very large eruptions offshore and even larger ones on land. So it will happen, but hopefully not for some time.
It's a good thing that you're up there doing this work, but it's not just the danger posed by eruptions. We need to know more about the seafloor because it's got valuable stuff down there, Richard.
It's got a lot of valuable stuff. The whole New Zealand seafloor it has, and that's something we're just starting to discover. These volcanoes themselves have mineral deposits of lead, copper, zinc, silver, gold. There's certainly interest from the mining industry, but these volcanoes also have very specific biodiversity as well, which we need to understand. So the potential is there for economic gain, but also there's the environmental impact to explore as well.
Yeah, dramatic times in many respects, actually. So when do you reach dry land?
Thursday.
Thursday. A nice trip back?
Very nice. It's gorgeous out here. Flat sea, beautiful day. Absolutely wonderful.
I'm very pleased to hear it. So you'll be relaxing now, won't you?
It's a lot better than New York, that's for sure.
Yeah, that's true.
It sounds quite terrible. Yeah,
it does sound grim. Richard, thank you very much for joining us. I appreciate telling us all about that.
My pleasure.